Hello everyone and welcome to the chapter number 66 of Blender Master Course Soft Body Physics. In this chapter, we'll be understanding about how the soft body simulation works in Blender, the various options available in the soft body physics, and to revise everything, we'll also be creating a simple jelly scene with the help of soft body physics in the end of this chapter. And for anyone who is new to this course, you can watch the previous 66 chapters from the link of the playlist given in the pinned comment. Now the first question which arises is that what exactly is meant by the term soft body physics? So the soft body physics makes an object to act like a clay or dough or anything which is soft in nature. Now to view it practically in Blender, let's go to the physics properties and from here select the soft body physics. Now we have applied this soft body physics, and in the 3D viewport, if I press the space bar to play the animation, then you will notice that nothing major is happening apart from the cube moving up and down by a small distance. Now the reason why it stays only at this position even after playing the animation is that the goal option in the soft body physics is turned on by default. However, if I turn it off and again play the animation by pressing the space bar, then in this case, the effect of gravity will get applied to the soft body and as a result it moves downwards. Now let's try to make it interact with a plane object. So for this, let's add a plane. So press Shift plus A, go to Mesh and select the plane, tab into the edit mode, press S to scale it up, and we'll be scaling it up 5 times. Now let's select the cube and move it up in the Z axis, and to make sure that this cube with the soft body physics interacts with the plane, we also need to apply the collision physics to the plane. So go to the physics properties and select the collision physics. Now let's select the cube, and for a better animation, press R to rotate it like this. And now if I press the space bar to play the animation, then the cube or the soft body will interact with the plane and it gets folded into a flat surface or a flat plane. Now to fix this problem, we need to open the edges category in the soft body physics, and over here you have an option called stiffness. So if I turn it on, it will make the cube stiff, and so if I take the pointer back to the frame number 1 and press the space bar to play the animation, then now in this case you can see that the cube will not turn into a plane object, but instead it interacted with the plane just like a soft body or a jelly like object. Now in the edges category, we have some more important settings like plasticity and bending, but to understand these, we need to have a complex model with a much larger number of vertices, and therefore let's go to the edit mode of this cube, right click and select subdivide, and in this way this cube is now having a greater number of vertices. Now the first important thing that we have here is the bending, and with its value set to 0 and also with the subdivided vertices, if I try to play the animation, then you will notice that when the cube collides with the plane, we see a kind of crumbling effect on the faces of the cube, and this effect can be influenced by the bending parameter. So we can keep its value anywhere between 0 and 10, but for now I'll be entering 2 as the bending value, and let's try to play the animation again. And this time you can notice that the amount of that crumbling effect on the faces of the cube has now reduced, and this is because as we increase the bending, the amount of bending stiffness on the object will increase, and as a result the crumbling effect will reduce. Now one more time, I'll change the bending value to 0.5 and let's try to play the animation again. Now this time also, on collision with the plane, the faces of the cube show the same effect but with a slightly lesser intensity as compared to when the bending value was equal to 0. Also, if I again tab into the edit mode and subdivide the vertices one more time, then now the complexity of the shape has increased, and with this, if I go to the bending parameter and enter 2 and play the animation one more time, then now you will see that the crumbling effect is still visible on the faces of the cube. So it completely depends upon the geometry that how much bending stiffness will be added because of the bending parameter. And for now, I'll be keeping the bending value at 0.5, and moving ahead, we have one more important setting in the edges category, which is the plasticity, and it basically controls the deformation of the object on colliding with some other object. By default, its value is set to 0, and therefore throughout the animation, we were not able to see any major deformation in the structure of the cube. However, if I increase the value of plasticity to 20 and try to play the animation again by pressing the space bar, then in this case you will notice that when the cube collides with the plane, it has major deformations in its structure, and this is because of the plasticity parameter. It kinds of create a dent whenever the object collides with some other object. You can also understand it in this way that whenever you hit a plastic object with a hammer or a similar tool, it kind of creates a dent on its surface. Similarly, in this case also, when the soft body will collide with the plane, the plasticity parameter will create a deformation or a dent on that particular area. Now to see the plasticity effect in a much better way, let's return back to the frame number 1, go to the edit mode, and let's subdivide the vertices one more time. So right click and select subdivide, and now if I play the animation again, then in this case the soft body or the cube will collide with the plane, and if I zoom in, then you can clearly see the deformation in the structure on this part of the cube due to the plasticity parameter. And also if I continue to play the animation, then you will notice that the deformation effect due to the plasticity is now applied permanently on the cube. Now to get the results which look realistic, let's reduce the plasticity value to somewhere near 5. Let's also increase the bending, and I'll keep it to a value value of 2. Now let's replay the animation one more time, and this time you will notice that when the cube object collides with the plane, the entire animation gives a much more realistic look than before. Now to revise what all we have done till now, we'll be creating this simple jelly scene with the help of soft body physics. So for this, let's go to the frame number 1. Now I'll select the plane, tab into the edit mode, and let's increase its size and then left click to finalize. Now we have this plane with the collision physics applied, but we need to create some more jellies in the scene that will collide with each other. And for this, let's go to the top view by pressing 7 on the numpad, select this cube, press Shift plus D to create a duplicate and place it over here. Let's create one more duplicate, let's place it over here, and in a similar way, we'll be keeping about 5 to 6 cubes in our scene. So let's select one more, place it over here, and yes, do ensure that they kind of intersect with each other, because in this way, when they fall down, they will collide with one another and form an interesting simulation. Now let's go to the front view by pressing 1 on the numpad, and we'll be giving some different heights to the different jellies in the scene. So I'll select this one, place it over here. Similarly, let's select this one at the back and move it up in the Z axis. Now we have a simple system of jellies in the scene, and right now if I try to play the animation by pressing the space bar, then you will notice that when the cubes will fall down, they are not interacting properly with each other. In fact, some of the cubes are even intersecting with one another, and this is because we have not yet applied the collision physics to each of these cubes. So to solve this problem, let's go back to the frame number 1, and with this cube selected, go to the physics properties and apply the collision physics. Similarly, let's do the same with this one also, add collision to it. Now let's select the third cube, go to the physics properties and apply the collision physics. Now with this one, we'll apply the collision to it, and finally the last cube, go to the physics properties and click on the collision. Now if I play the animation, then you will see that the cube objects will collide with each other like they just did around the frame number 30. Like here they were touching each other, but on playing the animation further, they collided, and finally this is how the animation looks. Let's replay the entire animation one more time. Also, to give these cubes a smooth look, you can simply select them, then right click and select Shade Auto Smooth. Let's do the same with the others also. So I'll select this cube, then right click, select Shade Auto Smooth. Similarly with this one, let's do the same with this one also. Right click, select Shade Auto Smooth, and in the end, I'll select this one, then right click and select the Shade Auto Smooth. And in this way, we have a simple animation of some jellies, and now let's work on giving some material to these jellies. So for this, let's first go to the material preview mode, and with this cube selected, go to the material properties, and first of all, I'll go to the base color and let's assign the red color to it. And right now, all of these cubes are having the same material because they are the duplicates of the one specific cube in the scene. Now to make it look like a real jelly, let's reduce the value of roughness to 0, then go to transmission and increase the value to 1. And with this you will notice that we have the material which looks like a real jelly. Now to assign different colors to the different cubes, I'll simply select the other cube, go to the material properties, and we need to create a duplicate of this material. So for this, click on this icon, and now the name of this material is saved as material.001. As a result, whatever changes I'll do in the base color will only get applied to this particular cube. Similarly, let's select this one, create a duplicate, and let's change the base color to the blue color this time. Now I'll select this one, create a duplicate, and change the base color to the yellow color. And in the end, I'll select this cube, create a duplicate of the material, and change the base color to the pink color. And with this, we have 5 different jellies having different colors in the scene. Let's also select this plane, and to give it a material, go to the material properties and create a new material. Let's change the base color, and I'll be assigning the dark blue color to it. Let's also reduce the brightness from here, and finally this is how the jelly scene is looking now. And with this, we are now ready to play the animation. I'll take the pointer back to the frame number 1 and press the space bar to play the animation. And so this is the final result. And with this, we now arrive to the end of this chapter. Today we learnt about the soft body physics in Blender, and we used it to create a simple jelly scene of different colors which collide with each other. So our next chapter will be the chapter number 67, Fluid Simulations in Blender. So don't forget to subscribe to our channel, press that notification bell so that you can get timely updates about the upcoming chapters. Thank you for watching, and we'll see you in the next one.